Hey guys, this is Guy here. The video you're about to watch is one of the many lessons I'm creating on KBTrainings.com for the course about the CCNA 200-301. So if you want to start or boost your career in the tech field, my CCNA course goes from zero to engineer. I'm going to teach you everything you have to know to take and pass the CCNA exam. And if you like what you see, go check it out on en.kbtrainings.com. Thank you and enjoy the video. All right, guys, Guy here. Welcome to the lesson number 8.1.3. We are going to talk about traditional networks and compare them to controller-based networking. We are going to cover these different points here. First of all, I'm going to define traditional networks and controller-based networking. And then I'm going to tell you the characteristics of traditional networks. And we'll talk about characteristics of controller-based networking. And then I'm going to compare the two and give you a summary on how these two types of networks can be different. So to jump right in, traditional networks are made the old way, where every device is independent and you do your management device by device. There's no kind of centralization. There's no kind of system that is managing all the devices together. That's the old way of doing things. So if you want to configure routing, switching, policies, you need to go or you need to log in every device individually to be able to set this up. So there's a lot of manual management and a lot of individual intervention from your admin team or your IT team. But when you replace that with a controller-based network, you're going to centralize things. Everything is centralized in the controller. So the controller is the main component of a controller-based network. That's where the intelligence of the deployment is coming from, and then all the devices are managed from there. This will allow you to have a lot of flexibility, scalability, and efficiency, and it's going to address all the limitations that you have in a traditional network. Let's go ahead and talk about a little deeper about a traditional network. These two images give you a good overview of what's happening when there is no centralization. We have an admin workstation here, and from there, we are managing each device individually using CLI with protocols like SSH or Telnet. Or we can even use the GUI with HTTPS as well. But the main idea is that everything is done individually. It's not centralized. So if I want to configure OSPF between the different devices, I need to go into each of them one by one to configure that. And we run into all those problems where we can have errors, we can have mistakes, we can have inconsistencies between the configurations. And that is just coming because we have a human in control, and that's a possibility. Even when it comes to, this is mostly for network configurations. When it comes to monitoring, we have an NMS or network management station that is connected to each device individually using a protocol like SNMP to be able to monitor and control the state of our network. So this is the traditional way, and here are a few characteristics of a traditional network. First of all, the control is decentralized. There is no central control. Each device has its own control plan and data plan. So each device is able to process its own data. It doesn't get any order from anywhere beside the configuration it received. And in the next chapter, we're going to cover control plan and data plan in a little more detail. So here we have a lot of manual configuration. The administrator is going to configure everything manually. Next, we are limited in our scalability. So we can add as many devices as we want because we are limited in terms of resources to manage those devices. So if you want to add more devices to your network, you need to build a bigger team because now you need more manual effort to configure or to manage everything. And a traditional network has a static nature. There's no intelligence or there's no any kind of dynamic way to resolve your issues or apply changes to your network, which makes it less adaptable. So while effective for a smaller network, when your network becomes bigger or when your environment is very dynamic, there's a lot of changes and things like that, this might not be the right fit for you. You need to have some kind of automation to meet the modern demands for agility and rapid scaling. So that's something you need to keep in mind. Next, let's talk about the controller-based networks. As you can see here, we still have our same devices, But now, instead of them being completely independent from each other, they are controlled by a centralized entity that we call the controller. That entity can be in the cloud, it can be a web app, it can be of any kind. Like I gave some examples over here. We have Cisco Epic, that is a good example of a controller. We have the Catalyst Center from Cisco. These are two examples of Cisco controllers. And we have all these other tools like Ansible, Puppet, Chef, SaltStack. What the controller does, as the name says, it's controlling our network. So the intelligence or the different policies that are running our networks are coming from the controllers. So the controllers, like I said, they can be in the cloud or they can be anywhere. They need to have access to the devices. And many times, all these devices are linked to the same controller. So the controller will be able to see all the different devices, and it's going to push policies, configurations, changes, depending on what you have set in the controllers. So you as the administrator, your job is to take care of the controllers. So you need to make sure the controllers are well configured, and then they are also connected to the devices. Once that's done, all the work will be done at the controller level. You have things like models or templates, you have scripts, you have all kind of configuration that you can run or create in the controllers, and that will be pushed automatically to the devices that are designated to receive that configuration. The good thing about this is that it's very scalable. So you can have 10 devices or 1,000 devices. There's no difference from your end because you only deal with a single controller. And in the back end, the controller will find a way using tools like APIs or specifically REST APIs. It's going to find a way to reach out to the devices, push configurations, pull the state of the device, and everything will be shown to you in the controller. So you don't have to go specifically in each device to know what's going on in there. So now we're going to cover a little bit of the characteristics. First of all, it's centralized. The control is centralized. You have a single controller that is managing all your policies and device configuration. You have automation and programmability. Changes can be applied across devices using APIs or templates. So from the device, from the controller, you can do some changes to a certain template and push it to all the hundreds or thousands of devices. And you have scalability, which means that you can grow as much as you want, and you have a lot of flexibility in the deployment of your infrastructure. This will easily adapt to dynamic workloads and new device integrations. We mentioned ZTP or zero touch provisioning that is implemented today by many vendors, where you don't have to do much. You have a controller. All you have to do is show the device where the controller is or onboard your device in the controller, and all the right configurations will be pushed down to the device. We have SDN or software-defined networking. This is going to decouple the control and the data planes, simplifying network management. Again, we're going to cover control plan and data plans in our next lessons, and this will make sure that all the control is done by the SDN controller, and the device only does the data plan. So controller-based networking enables faster response to changes, making it ideal for cloud, IoT, and large-scale enterprise networks. So it's more about scalability, and if you have a lot of devices to manage, it's much easier when you do it with a controller-based network. And then I'm going to end by showing you this quick chart here, just highlighting all the different features that we covered and how traditional networks do it compared to control-based. In terms of control, that is decentralized here, centralized there. Configuration, you do it manually on a traditional network, and it's all automated in a controller-based network. Scalability is very limited in a traditional network and very high in a controller-based. Adaptability, it's very low in a manual or traditional network, high on the network-based, and then its management is done device by device in a traditional network, and it's all unified through a controller in a controller-based network. That's all for this lesson, guys. It's as simple as that. We are moving or shifting away from a traditional way to do networking, where everything is done through the CLI. The CLI is still important, but Now you have a way to automate things. You have a way to manage a lot of devices at the same time using the kind of tools that I showed you earlier. And that's where modern networks are going. And that's why for the CCNA 200 301, you need to know all these differences so you can make a very informative decision when it comes to it. Or if you find yourself in an environment where they don't do things the traditional way anymore, you'll be able to find your way around it. All right, guys, I'm going to leave you a link to a document just giving you all these different features and going a little deeper. If you have any questions, you can send me an email or go in the community to ask your question. This is part of the CCNA course on KBTrainings.com. If you like it, don't forget to like it on YouTube and make sure you subscribe to the channel and go check out the website at en.kbtrainings.com. Thank you for watching. I will see you in the next one. Take care and bye.